Okay, you guys should have your Unit 9 notes out in front of you, Lesson 99. We did the first two examples the other day, and we're going to do the last two examples today. Now, as you can see, the note sheets, we pretty much used up all that space. So I am going to do these two questions, but I've just moved them onto a different sheet so that it'll give me more room. But they're right here. Okay, so these questions should match the ones that you have in front of you. Alright, this is going to require a decent amount of space, so you might want to take out a blank sheet of paper, or the very back side of your note sheet is blank. You can also use that one if you choose to. Alright, now my hope is that you guys are going to keep up with me. If we need to hit pause and you need to review some things more than once, you can. That's the joy of having a video. But my hope is that we all stay up with things here. Okay, we talked about solving rational equations yesterday by cross multiplying. But what you'll notice is on the left side of this equal sign, I do not have just one fraction. I have two of them. And I cannot begin to cross multiply unless I only have one fraction on the left and one fraction on the right. So I'm going to have to do something about this. And what I'm going to have to do about this is go ahead and combine these two fractions. It's a plus sign in between, which says I need to add them together. And that's exactly what I'm going to do. I'm going to take these fractions and I'm going to move them over here. And I'm going to work with those by themselves right now. And I'm pretend like that equal sign's not even there, and we're going to do the same process we did adding fractions with different denominators, okay? I would look at this and use my L is for LCM method, because I have to find common denominators first. And I would say the only thing that's going to go evenly into both of those is a 1, which gives me x and then an x plus 1. L is for LCM. And I am multiplying those values together. That's giving me a common denominator of x times an x plus 1. Now what I need to do is write two new fractions that have my new denominator. I have an x times an x plus 1. That's not a 1. And then I have an x times an x plus 1. And I have to figure out my numerators. The numerator of the first fraction was a 12, so I'm going to cross multiply. That tells me the new numerator is 12 times an x plus 1. I'll do the same thing on the other diagonal. Take the 15 times the x, and 15 times x is 15x. Now since they have common denominators, I'm going to go ahead and combine these. That's a 12 times an x plus 1 plus a 15x all over x times an x plus 1. Now before I go any further, I'm going to ask you a question, and obviously I won't be able to hear your answer, but I just want you to think about this a bit. Can I cancel the x plus 1 and the x plus 1? My hope is that in your brain, or some of you probably out loud, said no. Because if you have addition or subtraction outside of parentheses, you cannot cancel. That's bad. You can never cancel over addition or subtraction. Doesn't work. So the only way I can simplify this is to distribute and then combine like terms. I get a 12x plus a 12 plus a 15x. And that is all over x times an x plus 1. Now I'm going to go ahead and combine my like terms here. I have the 12x and the 15x, which I can add together, and 12x's plus 15x's gives me 27x. And then I still have that plus 12 here, which is all over x times an x plus 1. Now what I'm actually going to do in this situation is I'm going to go ahead and multiply out that denominator. Now when you hear that, most of you are probably thinking, why? We always factor. But when we are working with equations, we only want one group. I don't want two things being multiplied together like this. It makes it a lot easier for us to work with. So I'm going to go ahead and distribute out that x to both terms. Okay? Good. Now, the only thing we have done up until this point is add my two fractions together. I haven't even begun to solve this problem. These two fractions have now been added together, and I've given this as a total. So the only thing I've done is rewritten that in a different way. I still have to solve my problem. My new problem says 27 x plus 12 over an x squared plus an x should now equal 72 over 3x. The only thing I did is add those together. And when I added them together, this is what I got. Meaning, this is no longer two fractions being added, it is my solution. And I'm setting both of these values equal to each other now. Now I can go ahead and cross multiply because I only have one fraction on the left and one fraction on the right. Doesn't matter which order you go in, makes no difference which two cross products you work with first. I have the 72 times the x squared plus x is going to give me 72 times an x squared plus x. I'm then setting that equal to my other product, which is a 3x times a 27x plus 12. Now the only way I can simplify this is to drop my parentheses, and the only way to drop parentheses is to distribute. I'm going to take that 72 and multiply it by both terms, which is going to give a 72x squared plus a 72x. I'm going to do the same thing on the right hand side here. Take that 3x times the 27x. That's going to give me 81x squared. And then the 3x times the 12, which is going to give me a 36x. Okay, we're getting somewhere. Now, I should look at this and say, I have a quadratic here. I have x values that have exponents of 2. When I see that, you should think, set it equal to 0. I'm going to write that off to the side. Set it equal to 0. The only way you can solve a quadratic is to set it equal to 0. So I need to move everything to one side of that equal sign. I like to work with positive values, so I'm going to choose to take the values on the left and move them over to the right. Subtracting a 72x squared those going away, leaving me with a 72x is equal to a 9x squared plus 36x. And then I'm also going to subtract the 72x because I need to set it equal to 0. So I got to get everything out of there except for that 0. Zero stays on the left. And I have a 9x squared minus a 36x. Now what we're used to seeing at this point is we are used to seeing trinomials. We don't have a trinomial here because the only way to solve for a quadratic is to factor. This can still be factored though. I can take something out of both terms. I can take out a 9x. I'm going to go ahead and do that. If I take out a 9x, I'm left with an x minus a 4. And that's equal to 0. Now I can set my factors equal to 0. I set the 9x equal to 0. And I set the x minus 4 equal to 0. If I solve, I get x is equal to 0 and x is equal to 4. Now, wouldn't it be nice if that were our final answer? But unfortunately, we're not quite there yet because we didn't talk about something called excluded values yesterday. What excluded values mean is even though I get two different solutions, it doesn't mean both of them are answers to my question. I have to check. I have to put these values back into my original equation and see which ones work. I'm going to start with the x equals 0. That's 12 over 0 plus 15 over 0 plus 1 should equal 72 over 3 times 0. Now automatically that should send red flags up in your head. And it should say, hello, hello. I cannot have a denominator that is equal to 0. Ever, 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 ever. That is undefined. Meaning I know x equals 0 cannot be a solution. It is not a part of my answer. I'm going to cross it off. I would then test the x equals 4. Okay, to save a little bit of time, and this recording is going to cut me off in about a minute, I'm not going to go through and put it back in, but I'm just letting you know it does work. If I were to put the 4 back into this equation for x, I would get two solutions that are the same. If it works, then that is your answer. The answer to that entire problem is x equals 4. Yes, we did all of this work. All of that work to get an answer of 4. Seems a little silly. It is time consuming, but this is what I meant by second semester picks up a lot. Okay? That's question number 1 on your note sheets. Hopefully you got that done. Like I said, the recording's going to cut me off in a second here, so we'll stop this video and we'll start the second video to go over the second example.